স্ক্রিন দেখা যাচ্ছে কোনটা?
My dear student, colleagues, and all the viewers who are watching this program live from Facebook page, Physics Adda, and School of Astrophysics and Astronomy, and YouTube channel Pretam Kumar. So I'd like to welcome you all to our international physics webinar. So good evening to all here in Bangladesh, and good morning those who are watching from USA. So thanks for helping us throughout this year in arranging this special webinar. So as we know that we are staying in a corona pandemic situation, it's very difficult for us to continue our normal academic program. So we have to start our online program. I think you have already come to know that the Department of Physics, Pabna University of Science and Technology, has started its online program, including online international physics webinar. And we have successfully completed our 184th international physics webinar. Today it's our 185th international physics webinar. Today, we'd like to welcome you all to a joint session between our Department of Physics, Pabna University of Science and Technology, and the Department of Medical Physics, Tohoku University, Japan. And we have with us here today Dr. Rafiqul Islam Bhai. He's currently working as a research student doing his PhD in medical physics at the University of Tohoku, Japan. And he's also working as a principal scientific officer on leave at the Institute of Nuclear Medical Physics, Bangladesh Atomic Energy Commission, Dhaka. And he has already connected with us, so I'd like to welcome our speaker, Rafiq Bhai. So welcome to our international physics webinar for second time, and thanks for helping us in arranging such an important webinar on GATE with you. So before going to you, I would like to tell all the viewers and the students that you can also ask questions by commenting, and you can join with us by using this link. And I think you have already come to know the title of this today's international physics webinar. Title is the Monte Carlo simulation application in medical physics, PHITS and GATE code. And I think this will be very helpful for our students. So please stay with us and enjoy today's lecture. So Bhai, you can start your session. It's your time.
Okay, thank you. Thank you, everyone. Good evening. And almost in the world is and for just USA is good morning. So I'm very happy to join with this international webinar, and the host by the the very famous person now for the international webinar, Dr. Pretam Kumar, Associate Professor of Pabna University. So actually I'm very happy that I came again after 1 year almost. Last year of July 6 maybe.
Yeah.
So
yeah, almost
most of
1
this
year.
1 year. So actually today's talk or discussion is those are interested for the medical physics working beside lab. That's mean in the laboratory you can experiment. So just this is for the student, those are interested for my talk. Can you help me that one? Okay, so can I start today's talk?
Yeah.
Okay, so again thank you and welcome to all. It's today's talk of the international webinar. This talk is a Monte Carlo simulation application of medical physics. That's mean I will focus on the medical physics to the Monte Carlo application, and I will discuss about two codes. That's mean PHITS and GATE. Those are most of this related to the. So we can see what is our just the outline today's, the Monte Carlo simulation, and then GATE code, PHIT codes, and conclusion. Actually, this is just the name. If we can ask what is the Monte Carlo, someone can ask you, and we know that This is just the method of common name for the analysis of some types of random data. How can we create the random data? You know that the variety of stochastics, those are knows about this one. So Monte Carlo, it is not come from the others word. It's just some probability working like that one. And then if we say what is the simulation of Monte Carlo, so that is the good things. First, you can see the simulation, and that's the mathematical application to the computer. And what is the purpose? A real world problem we can solve, and we can predict what is the output with the various activities, that's mean action scenarios is like that one. So if we can see the short history of Monte Carlo, the method is developed by John von Neumann. Actually, this method is developed according in the duration of Second World War, and there was a big project of Manhattan Project in 1940 to 1947. Actually, this method is proposed about 200 years ago by Buffon. That's mean Conte de Buffon. He proposed at 1777, and the proposed things was that like a touching in middle. That's mean if you toss a needle on a rolled sheet, that's you can determine the probability. That's how can we find that one? In the next slide, you can see how to cross that one. So yes, first I can say that today's talk is not about the development of Monte Carlo and history of Monte Carlo and how we can calculate the pi value. Just I will discuss some first 2 or 3 slides. What is this? And then according to the history of Monte Carlo, you can find the pi value. How can? That's mean if you think a dartboard, that's there is a circle with radius r, and the board of area, say length and width is a, so the area is the a square, and then you can find the ratio. So the ratio is pi r square over a square. Interesting things, for pi value you should consider the radius of the circle is equal to the half. That's mean is a means is the twice r. So then that's the region is completely filled, and the ratio will be the pi equal to 4 multiplied number of, that's means later you can see what how can you calculate that one. So this is the ratio, you can find that one. So if you tries 100 times in this region, what happened? All our point is not inside in the YOLO, some points in inside and some the outside, and if you calculate the ratio, then you can find the pi value. So this is 100 tries. Then you can try the 10,000 tries, you can find this value, and so on. So this is the huge number, then you can calculate the pi value. But how many times you will calculate or you will try in the dartboard continuously. It is in practically is not possible, as I think. You need many times. That's why the Monte Carlo method is coming popular. We can calculate this value within very short times, like 1 or 2 minutes. You can calculate this number. You generate this number. After that, you can calculate the pi value. So there is a some option. How can we that one? So someone can ask why people interested for the simulation. Actually, simulation is a first of all you can say that is a low cost way of experiment, and there is a lot of option for repeat and modify just as you wish which parameter you can choose and how many times you can repeat until your expected value. And you can first you can solve analytically, then you can go to the your study. Sometimes you can examine the hidden quantities. That's when it is very difficult sometimes to find the analytical, but there is some disadvantage. Of course, every system has advantage as disadvantage. So it is time consuming, because if you will not get your appropriate value, then 1 day, 2 day, 3 day you are just passing with interest the simulation, but you will not get a appropriate result. Does not give actual, that means exact solution. So there is a some error between the experiment and simulation result. It should be, because in the simulation that is all point are fixed, but in the practical experiment that is not fixed, so it's come from the experiment. That is the difference. But sometimes we should think your model is correct, there is some bugs. If it is possible, you should some bugs. So if that occurred, you can see the bugs. What you can think? Alternatives, that's mean analytic solution again, and you can do again experiment. Okay, so if you think the simulation is good for you, then what is the mechanism of the simulation? First, you should think about the general method. Which method you can choose, not a problem. Then you can create the random number. That's mean say you can use 1 or 2 or 3 or 4. That's mean not a factor. And then you work for the sampling. You know those are working. That's mean physics, chemistry, and maths. So for experiment, you know the sample produce and like that one. So if we understand the general of Monte Carlo method, so this is general, it's not the specific to the any field. Actually, Monte Carlo method is a multidimensional field, and it has a lot of fields, and you can work in the particle physics. How can you use? You can calculate the any types of parameters by the interaction, any with say proton-proton interaction or others. Quantum field theory, it is very interesting. You can calculate anything. Astrophysics, molecular modeling, semiconductor device. So before the real device creation, you can create that one. And the most of this application in the medical physics I will discuss today. So others field are, and also the light transport calculation, traffic flow simulation. This is very interesting. How can you calculate the traffic flow? So if you modeling a traffic in your city, so how many so you can consider just one traffic point, how many transport are crossing, say 1 minute. So if 1 minute, so what is the happened? You can just simulate by the everything. You can calculate the velocity of the say bus, truck, car, like that one, and also the environmental science and others. So that is the different. I will not discuss more about that one. We are focused today the medical physics. That's mean the application of Monte Carlo in the medical physics field. So which branches are included in the medical physics? As we know that in the medical physics we have four that's mean the fundamental fields is like diagnostic radiology and the radiation therapy, nuclear medicine, radiation protection. So in the diagnostic radiology, that's mean the CT, PET, X-ray, and others device you can create it. Here is the spec is the two detectors. So this I simulated in my laboratory. And if we go to the radiation therapy, this is the LINAC, just the simulation and the water phantom, and the photon beam is just interaction with water. You can see the track, it's very easily. So that is the thinking for the simulation to the medical physics. You can see what types of interaction now and what is the particle creation. Primary particle is interaction and the secondary particle is created inside with the interaction by the others element, and the nuclear medicine. So expect PET both are nuclear medicine. This is the two source inside the PET, and this is actually the small element PET and the high resolution I will discuss in the later. And this is the shielding calculation. So the source is here. This is your concrete, how much concrete is need. Then you can put a detector here. If you got some value here, then your concrete design is not appropriate. So it's before uh, build a building, like a creation a building, you just calculate in the simulation what types of materials and how centimeter depth or thickness is need for that one. Any type of materials you can use, and your result after that you will go to your experiment or practical works. It is very interesting. So let's see what Monte Carlo codes, how many. That's mean lot of Monte Carlo codes, but most of this focus is the name of the Monte Carlo. That's mean the code is developed by the many developer for their own activities or their laboratory activities or the regional activities, but they focused the main theme comes from the Monte Carlo. So initially there is a two main familiars. That's mean the general purpose and also the dedicated. If we see what is the general purpose Monte Carlo code, is the Jan 4, the very famous and popular is the toolkit, then gate, PHITS, MCNP, Flowcard, Topaz, and so on. There is a lot of laboratory based or I told you the regional based code, that one. And what is the advantage of this general purpose code? Can be used for analytically. That means anything you can use. There is a full physics description, but is the comparatively slow. Dedicated is fast, but restricted is physics implementation is really difficult to. That means the simulation should need some time to calculate appropriate interaction point to point. Because if you go to get your value to voxel by voxel, then you should consume time. But if you are interested to very fast, then your result it's not will be good, that one. This slide is just the information or the feature of different codes. So who are the developer? Those are interested not only medical physics and other side, you can choose any one or others code according to your. If you are interested to compare your result or if you cannot trust what I am doing, so you can think the other code and then compare your result both. So Jan 4 is developed by the Sun, Fluka also Sun, but it is the Italian nuclear physics networking. This means that the Sun also included. Fluka is good. Interesting things, the programming language, most of this code is used, very fundamental programming is Fortran and C++. So it's if you are thinking that you will work with the simulation, then you need some programming knowledge. That's the very basic programming knowledge. So C or C++ or Fortran or like that one. Today we will discuss the gate and PHITS. So actually, GATE is developed for the nuclear medicine and initially, but now it's working for the wild field. And the PHITS is developed by the Japan Atomic Energy Agency and some others collaboration and their language. And it's very easy. I will discuss in the later. First, let's go to the GATE code. I can discuss that one. What is the GATE? Someone said, because this GATE term is very familiar with the electronics. Those are engineer or physics or applied physics student, they can understand the GATE. But in the simulation, the GATE is the name is different. Is the G stand for the giant 4 application for tomographic emission. Now is others, not only this field. So what is the giant 4? Giant 4 actually the geometry and tracking. That's mean first you should produce or develop a geometry, then you can find the tracking of this others element inside the geometry. That is the theme, and the 4 is stand for the version. Now the giant 4, before giant 3, giant 4, like that one. And it is the platform of the simulation passes particle through matter and also using Monte Carlo method. So this is means the, so what is the Monte Carlo? Monte Carlo is the probability distribution function. That's mean in the interaction you can see how many interaction happened in the point. That is the distribution and that is the density. So probability distribution or density function, like that one. So GATE is an open source software. I also told that one, and you can find the GATE in the OpenGate international collaboration link. It is written by the C++, and you can be used in the any platform. That's mean Linux, Unix, Macs. But be careful, indirectly you cannot work GATE code in the Windows, but there is option I will discuss in later. And GATE is user friendly, so those who have no idea about the C++ or Fortran, no panic. GATE is working by some macros file. You can create that one. So no need to C++ writing because we are afraid programming. So, and GATE can simulate SPECT, PET-CT, radiotherapy treatment planning, or others ion therapy. So any types of simulation you can create by this GATE. And interesting things, it is explicit modeling of time. That's mean, and when you create a detector and you create a source, radioactive source, so there is a decay time. So that is we call is the explicit modeling of time. So it's very interesting. And how and when the GATE is start. So first developed is 2002, and the public first public release is 2004. And today there is a lot of version release available now 9.1. It's very interesting. You can find in this website. I will discuss in this next slide. How to use Gate or how to get Gate. Sorry. So those are very beginner. That's mean who have no idea about simulation. For whose are recommended the VGate. VGate is the virtual machine. How to install? First, you can install the virtual box in your PC. That's mean laptop or any type of personal computer or like that one. Then you can download the virtual gate machine from the OpenGate collaboration. In this link you can find that one. After that you find, well, so this image will, you find that one when you install the gate in your laptop. That is the virtual machine, and that is the, so today's lecture is or discussion is just the introduction and how to you get and how to you install, but it is not possible so to describe every step of the installation. So those are interested, you can contact in later, or you can follow the procedure available in this website. Every step you should follow, then you can install in your PC without any hesitation or any problem. But if you face problem, you can contact with me or others person, that one. Those are advanced. They can install Gate in the Linux platform or Gate Docker frameworks. For details, you can visit this website. And so when you install your Gate code in your PC or laptop with the virtual box or Linux platform, then first you should go to the input file. As we discussed that Gate is based on the C++, but the input file, it is very easy to create just a text file. So first you should open a txt file like a notepad++, and you can save it, the extension as .mac. For example, my first simulation.mac. You can any type or name you can choose. It is depends on your on mind. Then you can create the file. So when you will go to create the input file, there is a lot of parts. You just write step by step. So the different parts included here is the very zigzag. I will discuss step by step. First part is the, you can choose that the visualization. That's mean when you will run your code, then you should first view what you did. Otherwise you cannot understand. So first you should the visualization. So the get code visualization use the that's mean OGL SQT. That's mean the Qt mode equal the open like that. And say you can choose the angle, you can choose the zoom function, other things is really easy, but you should follow. When you go to write your code, then you should start with the slash sign, then step by step you should if you miss just one point, say visualize, then volume and others, but order you should be correct? Otherwise, your code will be not run accordingly. You can find the error in your terminal. But when you get error, you should check what types of error. The gate code explain your error in this play. So let's the second option. So if you create a visualization, then the geometry, that is the uh, main point. What that's mean which type of geometry you are interested to draw. The geometries include two parts, volume and materials. Say you are considered like a sphere or any types of rectangular volume. So that is the outer shape, but inside you should put the materials. First you should write the slash gate slash world slash daughters, then name. I just discuss only one point. What is the daughters? What is the world? So first you create a big world. If you consider you are working in a laboratory, so in a laboratory there is a big room, say 15 feet over 15 feet. That's mean a room, but inside the room there is a some decks. So in the simulation, world is the room. You first create a room. After that, you choose the daughter. So the desk is the daughter in your room. After that, you just insert. So in the desk, which one you are choose? Just your desktop. So you put the desktop in your desk. Same as in the simulation, you should insert the box or any types of geometry volume you can choose, not a problem. Then step by step which size for you need you can choose. After that, which materials you want to include inside the box and which color you want to see in the visualization. You can choose red or blue or green. It's up to you, but be careful. When you create your code, you should follow like set color. Here C should be capital. If you use set color C smaller, then you cannot see the color or your code will be some error like that one. Interesting part is the physics, because you know that physics is the big part in the simulation. Why? Is the interaction. That's mean in the physical process, if you choose the your source like a proton beam or photon beam, say gamma, then you should mention what types of physics list you want to see that one. You should read the manual. There is some name, say E electromagnetic. Here is E, M means electromagnetic standard, underscores optical 4. So this is one type of physics list. If you use this type of list, you can see some types of interaction. If you choose say instead 3 instead of 4, you can get little slightly different result but almost same, because you are using the electromagnetic interaction standard is the same as, so just you change that one. So you should choose the source. What type of source you are interested to interaction with water? You can either proton or photon. That means there is actually two types of source, is the charged or uncharged particle. In here, I will just discuss you for the 20 MeV monoenergetic electron source. The energy is 20 MeV, and where you put the source position. The source position is the z direction. So 0, 0, and 100. That means X position 0, Y position 0, and Z position 100 centimeter far from the center. This is the point source. And that's mean ISO means isotropic. That means is not a unidirection. And you can choose others. If you need, you can choose, or no need problem. If you are interested to show the source color, then you should use this option. After that, the output. So it is interesting. You should also select which type of output you want to get. If you are very expert in the root analysis, then you just save your output file as like the output.root. So which type of data you want to get? Dose distribution. That's mean in this experiment I discussed the water phantom, and I just use electron beam. Then the electron is interact with the water. We know those are working in the medical physics. So there is some electron is deposited their energy per mass. So this is the dose. So you are wanted to see the dose with depth, dose distribution. So output root, or easily if you can analysis by the Excel file, you can save as the output.txt file. After that, you just very easily. And other parameters you should choose. What types of you choose the dose distribution, so it is true. If you are not interested for the other things, then it's false. And you should select which surface, that's mean so volume 1, you choose your that's mean geometry, like that one, step by step. After that, other things, and which direction you can choose, it is depends, just you should read some manual, you can easily understand. So if your input file is ready, so how can you run it? In the terminal, you can just write gate dot gate, that's mean gate is the name of the operator, and main dot mac, that's mean you, if you save your file as the main dot mac, then you can use that one, otherwise you can use others name. But if you are interested to see the with visualization, it is time consuming, but it is very fast. You cannot see in the window there is interaction. So gate, you choose the qt slash qt, sorry, hyphen qt. Then you should choose your file, which file you choose here, like that one. I will show my screenshot is very easily by this Linux. Let's see, my file is in the desktop. So first, in the Linux, you should make directory, that's mean copy the directory of desktop. Then you can check the list which type of folder inside there. After that, you find the my code and main dot and main understand g4.mac. So after running, we can see this window, and that was input the G4, that's mean giant 4. I just simulated this one only for this lecture. So it is very easy to launch your code by the Linux terminal. One thing I can add here, if you will work with the virtual machine, inside the virtual machine, you also find the Linux terminal. That means Gate code you cannot run without Linux terminal. So you should know the fundamentals about the Linux operation like that. Let's see what is my application of Gate code. In our laboratory, this is the positron emission mammography dual head machine. We developed this one, very high sensitive detectors. It is the actually we can say this one now is the prototype, and we are working for the proton dose verification. How can we work in this? Our full system we simulated by this Gate simulation in the video. This is the video you can see here. Sorry. Why is it not? Sorry.
Bhai, you can escape and then you can run
Yes,
from your PowerPoint.
yes. Just sorry that one. Okay, I understand. Okay, can you see now? Yes, this is
Now it's
the
okay.
yes visualization. So when we create our system, then we just show the all site by moving 3D movement. You can see that one. Thank you, Pretam, for the cooperation. Okay, and this video you can see the proton beam interaction in the water and is stopped by the interaction, and a lot of proton is look here, and you see, and you can see also the secondary interaction, and here is the proton is all the proton is stopped by this. So it is really interesting. And after stop the proton, this proton is interact with water. You know that in the nuclear interaction, that's mean the some positron is created. In our detector, we detect the annihilated positron, that's mean the gamma. So first the positron is created by the proton interaction with water. After the positron is also interacted with others, oxygen or element in the water, then the 2 gamma is detected by our detector. And interesting things, we can understand this gamma is come from which point. So in the this is the different field. If I have time, I can discuss in the later the proton interaction and the positron creation and the gamma annihilated gamma and which part or like that one I will just show. And This white point is the my source position. So I put my source is the 50 centimeters far from my water phantom, and then the uh, proton is interact with water. After that, we can collect the data like that one. Here I will not discuss. I just show how it's work and how can we see by this simulation. This is interesting. So this is the finishing of PHITS code. Now I will move, sorry, get code. Now I will move to the PHITS code. Actually, someone can ask why the two code. In our laboratory, we work another code is Topaz. That is our goal in future. We can compare our result with 3 or 4 codes, and we will find the error between the two codes. And we are working in the machine learning procedure in future. That's we should learn more codes for the same experiment. So PHITS, actually the name is the comes particle heavy and ion transport code system. So it is a general purpose Monte Carlo particle code, and this is the developed by the Japan Atomic Energy Agency, as I told first, and this is the platform. So the good news here, you can use in the Windows. So PHITS you can use in the Windows, Mac, and Linux. It is very user friendly. Capability: this code is transport all types of particles, neutron, protons, ion, electron, photons, so all, and with the heavy energy. It's tera electrovolt, so it's huge energy, and everything inside their package. That's mean you don't need to install other things. It's like a virtual machine, but it's not a virtual machine. So you can work is a real, like a real machine, but included everything. So all these things inside that one, like a source file, libraries, graphics, everything. And this application in the accelerator, in the radiation therapy, and also space and geophysics are like that one. Good news that although this code is not free, but that's mean not open, but you can get in the free of charge by submitting application from PHITS website. Just in the next slide I will discuss in that one. So what is the user interface of PHITS? It is written by the photon, and the input file is free format text. Here the same as the gate, but little bit different. In the gate you should create the mac, that's mean your extension should be mac, but in the PHITS not necessary to the mac. You can save as your file like my simulation.txt or my simulation.inp, any type of format. You don't have written or compile photon programming. In the geometry they use the GG format, that's mean get graphics format. Graphics is Rayleigh angel type angel, those are working like that one. In the three-dimensional view you can see the paraview software install. After that you can show this type of image in this. Tally means the output. So what types of output you want to see, like if you want to particle fluence you can see, if you want to see the heat deposition, if you want to see the particle yield or production. That's mean what types of particle is produced by the interaction of proton with water or with the human body or with the bone or with the fat or any types of that one. And the output data also you can find any types: text data, histogram, and also the contouring image. So it's very interesting. And the platforms, as I told you, that one Windows is good, and also Linux and Mac. How to use feeds? So as I discussed, that feed is not open, but you can get it by following this website. So you need just there is some subscription with the your application, then they will give the license. After that, when you will get the license, the FITS authority will send you the zip folder including FITS and all others instruction. So when you will visit the FITS website, you can see this type of page. Here is a lot of tools bar. You can just check as you want to see, like that one. So how to use or how to run FITS in the Windows? It's very easy. Just select the input file, then right click and send to the select FITS. So like a refreshing button, that's mean we are very interested for our computer refresh every times. This type of just right click and then send to your input file to the, you can see the FITS and you just put. The Mac is little bit different. You just drag and drop your input file to the FITS icon in the Mac. And Linux, in the Windows, you just, I did not included this part, but I just discuss here. Just you should write something fits.sh, that's mean fits.sh and choose your input file like that one. It's not a difficult. So main components of input. What types of input you should? Same as here, I just discuss about that one. Any types of simulation code you are using or you want to use, some parameters are fixed for all codes. That means geometry you should choose, source you should choose or create, then output or tally you should that one. So these three parts, but visualization and data output file processing, that's mean what types of output you want. This is slightly different of each code, but almost same, the three fundamental components. What types of that one? In the same, if we discuss about that one, say my our first input file is that like a lecture 01.inp. That's mean I told you you can use .txt, not mandatory inp. Inp means input file. First you should your title, which title you want to see. You should mention your name, then parameters. What types of parameters you want to say, I will discuss in the next slide. Source you must define. Materials, here in the source and materials cell. In get code, we discussed that one, volume and materials. Here we just say surface and cell, almost same. Then the output, this is the output tally, that's mean track or 3D show or like that one. Track mean you want to see the proton track inside the water, you can just mention that one. And then you should write the end. Interesting, you also should follow the bracket. Which type of bracket are using? This you should must use the third bracket or like that one, or close bracket or others. That let's say for example of an input file. So title, first I say the proton beam in the water phantom, just anyone. Parameters, this is the incident parameters, is called the incident 1 type 1. And how many times or how many field you want to see, this is a little bit advanced things. So that's mean if max CAS 50 and max base, this is the base number. So there is a 2 base, and every base we have the 50 points. So in my work, or this according this input file, just 50 multiplied 2, so 100 points are interaction in your code, like that one. Then you select the source type. There is a different type of source, because so type 1, type 2, type 3, there is a details explanation in the materials. That's mean yeah, materials and method option. And the projectile, you should select proton or electron, like that one. And the direction, once mean the unidirection, and if you use 0, then is the isotropic. And the radius 0, that's point source. Z0, Z1, that means Z position of the source. Here I put that one in the center. And the energy 150 MeV. So no need to mention 50 MeV, no need. That's the system developed already. After that, materials, I just use the water. So how to write your materials part? Just material 1, water. So how to write the water is, you should space 2, that's mean this is the water, we know that one. So the ratio is 2:1, oxygen and hydrogen. You write according to that one. But a little bit some tips and tricks to write. Surface, you should select the surface. What types of container you can use, like a spherical or rectangular or any types. So here surface of sphere, I choose the sphere with 10 centimeter radius from the origin, SO. So this 10 is the number of surface. This is the number of surface. This is the surface code, that's mean sphere, and this is the radius. Just the explanation. And cell, so cell inside the surface. So you mention the cell number first, and the which type of materials you include. So this one is number of materials, so and -1 the density of the materials, and -10, that means the surface. This 10 is the surface, and minus mean inside. So you are want to put your water inside the surface, so you should minus here. Another volume you should, as I mentioned in the or discussed in the gate code, you should select a word. But in PHITS we did not mention like a word or like that one, but you should create a volume. So This is 101 and outer part of this one. So this region is outer side of my water phantom, like that one. And this is the track, which type of output you want to see. So this is the three-dimensional x, y, z. It should x maximum, x minimum, y maximum, y minimum, z maximum, z minimum, and which axis you want to get the output. I just choose xz to see and others parameters. After run the code, you can see this type of window is open in the terminal output. I will not discuss more that one, and you will find the PHITS.out. This is the system built already. After that, step by step your parameters will be found, and then the visualization of your result. So in this case, that was I chose the 10 centimeter radius of water phantom, and the water is inside and the color was green. You can see this is the z axis, this is the x axis, and here this is the track EPS file. So this EPS file result, you can see the track, that's mean interaction of proton, and with you will not see here the water. You can see the proton track and the secondary interaction track, and this is the color, but it's so like that one. And in this slide I will discuss about my application of PHITS code to the dual head PEM. So this is, as I mentioned, this is our real system, and this system is simulated by the PHITS, and in the output I found the depth dose. As we know, the proton is almost dose is deposited here. According to the color bar, you can show the red is the maximum. So all this here, our target is to find the what is the secondary particle is produced. That means the some radioisotope is produced with the interaction by proton. So here I will just, for example, explain the N13 production. So here we can see the N13 production, and in which region almost in here is produced. So this is the 2D view. If we see the 3D view and reconstruction image by Python or others one, you can see this type. So this is the dose. We can see the three-dimensional, and this is the in nitrogen 13 production 3D view. With the matplotlib we plotted this one. So this is our work, and now we are working feeds and get codes, and this one. Actually, I am now working. I am not expert, so we need many things to learn Monte Carlo simulation. It's my work is also very beginner, and today's discuss also just the introduction. Those are interested to work with simulation. Why with simulation need I discussed, and in the conclusion I just say need that one. So Monte Carlo simulation is an important technique to study the medical physics. We can say there are different courses dedicated to research or in clinical application in the medical physics. And GATE is a as told that Jan 4 based and the widely used for medical physics application. PHITS also is the most widely used Monte Carlo code, and in generally for Monte Carlo course we require some knowledge in physics concept and programming skill, but now some courses are designed That's mean very user friendly. Sometimes require no programming expertise. In finally, I can say in time of social distance, temporary lab work, that's mean closer are working and working from home. So learning Monte Carlo simulation code, that's been a good time for you and providing a tool to continue in your research from home. So this is the discussion of today, and I just focus the last part of the conclusion. Let's see, you can work with the simulation from your home and you can contribute in your work in the research. So thank you everyone. Thank you for listening. Thank you.
Thank you, Bhai, for your wonderful presentation. So I just got one question in inbox. So the
Sure.
student yeah, has asked that do we need Jan for do we need to learn Jan for gate?
No, yes, sorry. Thank you for your question, and it's interesting things. Jan 4, you know that one, but not in the beginning. In the first, you can start with the virtual machine, then just the mainly what is the Jan 4 is included to the gate. Jan 4 one kinds of database, and Jan 4 is writing by the C++ code. So if you have idea in the C++, then you can read, you can understand easily. But uh, initially I told no need to learn Jan 4 to learn gate. Thank you.
Okay, thanks. And we have a guest from Japan, MD
Okay.
Khaled Hussein Bhai. So I'd like to welcome him. So Khalid Bhai, can you hear us?
Yes, can you hear me,
Yeah, yeah,
Rafiq bhai?
yeah, yeah.
Sure.
Yeah.
How are
Thanks
you,
for
Rafiq bhai?
joining with us.
Thank you. I'm
Actually,
fine.
I'm interested your talk because I am working on fusion reactor materials, the hydrogen
Oh,
interaction.
it's good. Interesting.
So yeah, so I have also the access of the PITS, but I am in the beginner. I'm actually don't use. I'm using the experimental research. So, but I have planned to learn it next 2 months. I have planned to learn it only the PITS. I will use my time because I will submit my thesis. So I
Okay.
have some question to you.
Sure.
Why you choose two different code like Gent and PITS?
Okay. Thank you for your question. Actually, in our laboratory, first I start fits code my work and we got our result. Then our supervisor and we are thinking we should compare our result with another code. Then learn gate. Now I am working also the topaz, you know that another code. And also in our my uh, thesis work or my PhD work is included also the machine learning. You know that the artificial intelligence, when you will work to the machine learning, then you need to more course result to implement your final machine learning result. That is our goal, like that one. But one code is enough to your experiment if you want to interested to work anytime.
Oh, maybe I understand your point. To justify your result more and more, and that
Yes, yes.
deviation of your result. Okay, because yeah, your work is very interesting. So as I understand, maybe is it possible to get all types of simulation using all types of PITs, like all types of Monte Carlo simulation code? Like if you use the gate and PITs, different research areas, scientists can they do the same types of research by using all types of code? Is it possible?
Yeah, thank you for your question. Yes, if you that's mean in the fixed future, if you read that one or get future, that's mean what types of interaction there. If you are interested to see the say Newton interaction, or neutron proton interaction or others interaction, then light you can apply anywhere, but depends on the knowledge. First, the theoretical knowledge of this side which you want to see. Simulation will not give you anything. Simulation will give you everything if you input according to your demand. So I think when you are working your feeds, as you told that one, as I know, maybe the October there is a feeds course to English course by the JEA. As you got the information.
Yes, yes. About 2 years ago, I already complete the course.
Oh,
PHITS 2.
you are already registered. Okay, it's good that one. So it is better. You can, so in the shielding calculation or the others interaction or the any type of nuclear interaction or any type of energy calculation, say if you want to apply in the semiconductor, if you want to calculate the voltage define same, you can choose your parameters. Everywhere you can find that one, I think so.
Okay, so if I ask you a question, because you have already two different types of code knowledge, and maybe you face some problem and you solve this, so
Yes.
you have some idea already. So if I ask you, so which one you feel convenient, like Gen 4 or
Okay,
PITS, and which
thank
one
you
is
for
good
your
for designing your idea? Yes.
question. Yes, yes, PHITS is really easy and user friendly because PHITS no need to learn Linux, no need to learn C++, no need to learn Fortran. Just you need to learn only the input file how to put. It is initial state. It's very easy, but when you will get advanced, then you can learn others C++ or other things, because when you will go to the analysis, then it will be. But if I say for the on gate code also interesting and user friendly, but first you need some tips and trainings from others. But fits no need that one. You can just show their presentation slide step by step. You can run a code, but fits is gate you cannot run directly, because in the gate code there is a little bit different to the database. So gate code is using the giant 4 database, but fits is use the uh, Japan developed others database, and this database is included, that's mean the package.
Source file. Yeah.
But gate is not package. If you install in the Linux, then you should first install the giant 4, and then you will compile. That's mean you need to compile the gate code which types of database you are included in your code. Telling that I'm very happy, Mr. Khaled, to ask your question. Okay, you can continue any problem,
No, no,
question.
I actually not so much question, but
Yeah,
I
that's
am
the
very happy
discussion.
getting
Okay,
your
thank you.
code because I already forgot, but I give the reminder in my mobile, so I get
Oh,
I already
Yeah.
sleep, but I start again. Okay. So
okay,
next one
same.
is so every types of simulation we need like a supercomputer or fast computer. It's better to get the result very quickly. So based on your experience, what do you think for PITS or GENT? Is it
Okay.
necessary the
Yes, this is
supercomputer?
good question. I
How much?
also I forgot to explain in my discussion. I just say that one you need supercomputer, but not in the primary stage, in the final stage. But in the primary stage, you can start with your laptop or with your just laboratory PC. That's mean just a simple configuration, say 4 GB RAM or some hard disks. Why? Because first you need to learn how to run your code. So first, you don't need to put many random values. Just you can say only 10 proton, then you can see your interaction. You can get the result very few. But when you want to get the final result, say you want to put the 10 100,000 proton interaction, okay, then it takes time. In this case, you need to like a supercomputer, not supercomputer. In my laboratory, we have the access to the supercomputer, but I did not use supercomputer. I just use my general laboratory computer and working. So I think so is your laptop is enough. In my laptop, I am installed there. Gate and PHITS both code and Topaz as well.
Thank you. Last question. This is relevant to your expertise. Maybe
Okay.
I know before, but I already forgot. So again, I want to ask you about proton therapy. What does it means proton therapy? As I understand proton. So why I'm asking, because I'm also working with the proton deuterium heavy water. So it's interaction with the materials. So you are using maybe proton beam or something for the radiotherapy or something. So why
Yes.
you choose the proton beam? Why not deuterium beam or others? Why proton beam? Yes. And what is the proton therapy? Please explain a little bit.
Actually, you know that the radiation therapy is means there is a two types of particle is used, charged particle and uncharged particle. So the heavy ion means the carbon before used, and also the uncharged particle is the only the photon. That's mean the linac we are using. You know that in our atomic energy commission. But why proton? So proton, there is a good properties of proton when the proton is interaction with inside the body or water or other element. It's there is a good properties of the Bragg peak. You know that. That's mean at a certain point, the proton is deposited all the energy at the point. So our target is the cancer cell damage by the radiation. So if we proton interact with the cancer cell and all the energy is deposited at the cancer at the point, say 5 centimeter depth of your body, that's mean in lungs, you have a 2 centimeter radius of cancer. Then if we use 80 MeV of proton beam, then the proton is all deposited inside the cancer. After that, the cancer will damage according to the treatment protocol. It's not, I am just saying the primary things. But photons, I will discuss in the detail. But photons, there is a no Bragg peak. So the surface dose is high. That's when photons just decay with the square inverse law. So the energy's deposition will not high at the cancer point or position. So after 10 years or 20 years, photon therapy will be go away from the market. The proton and heavy ion carbon therapy and proton therapy will be available. Why not carbon therapy is good against? Carbon therapy also good, but in the carbon therapy there is a trail dose. That's mean proton and carbon both have the Bragg peak properties, but in the trail carbon also uh, deposited some extra energy, but proton no, there is a sharp peak, but carbon is little bit tail. That's why. And the deuteron is that's mean you know that the deuteron is the heavier than proton. Okay, so you should more energy to accelerate, and deuteron also there is no the how can I say the others interaction like a Bragg peak energy deposition or interaction by this others element. like that. And I'm also here I am can say that one I am not good experience of the deuterium therapy, and I did not hear that one. I will
No.
study
I'm
about
just
that.
wondering because I'm working with proton, deuterium, tritium, heavy water. So all are the
Okay.
light, all are the isotope of hydrogen. So I am interesting. So why not deuterium? Why proton? Yeah. Thank you very much,
Okay.
Rafiq bhai. Best wishes for your simulation and research life. Hopefully, we will meet again soon in BAEC,
Okay,
and
no problem. We can discuss now
yeah, we
more
can
and more.
do. Yeah, we if we get some idea or if we have some chance, we can do some collaboration if possible. So
Sure,
thank
sure,
you,
no problem.
thank you, Pabna.
Thank
Thank
Khalid
you.
Bhai for joining with us. So we will arrange a workshop on route, Janfor, and gate. So maybe you can join. So date maybe June 26 and 27 maybe. So we'll let you know later by sharing the poster. So
Yeah, thank
thanks,
you.
Mohammad Rafiqul Islam Bhai and Khalid Hussain Bhai for joining with us. So
Thank you.
this is maybe the uh, a new type of things for our student simulation type of webinar. So that's why we get less question, but hopefully as you discuss this thing very actually general way, so that anybody who are new in simulation, they might understand. And when we'll start our workshop, then those who are present today, they might be benefited, and hopefully in near future we'll find some researcher who will join our this type of simulation and develop the course in next medical physics in Bangladesh, and hopefully we'll get a new type of medical physics code with you in Bangladesh. So thanks
Thank
for
you.
giving us time, and hopefully we will arrange another webinar, but first workshop. So thanks for accepting our invitation for a workshop also. So
Thank you to you.
have a nice day, bhai. And maybe it's a midnight, like a midnight to your part. So
Okay,
good
no
night.
problem.
Yeah. So hopefully everything okay in your part. Maybe in Japan are doing well in COVID. So the rate is increasing now in our country. So
Yes,
maybe you
I
have
know
some
that
relatives and
only.
your family. So we are in danger now. So we have to follow the health rules. So thanks again. And we would like to say thanks on the behalf of the Department of Physics, Pabna University of Science and Technology for accepting our invitation.
Okay, thank you
Bye for
everyone.
today.
Thank you for listening. Okay, now
Yeah,
you can
bye for
stop.